So now it's time to connect integral calculus to differential calculus. So you remember last time we looked at the integral as the area underneath this curve. So let's say we have some function, big F of t, that's the integral from t0 to t, little f of t dt. And now let's take its derivative. So when we do that, remembering our formula for the derivative, this is 1 over, the limit as delta t goes to 0, 1 over delta t. This is going to be the integral from t0 to t plus delta t, f of t plus delta t dt, minus the integral from t0 to t, f of t dt. Right? Now one property you might remember with integrals is the integral from t0 to t we'll say the integral from t0 to t plus delta t f of t dt is the same thing as the integral from t0 to t plus the integral from t to t plus delta t f of t dt. So in other words, the difference between these two integrals is just a single rectangle of height f of t and width delta t. So in other words, the derivative of big F with respect to t is just the limit as delta t goes to 0, 1 over delta t times f of t delta t, which is just little f of t. So in other words, the integral is the antiderivative. So df dt is equal to f, and f is the integral of little f dt. So this is the relationship between a derivative and an integral. So you might have noticed that I called this function that we used before the velocity. And remember that we said the velocity is dx dt, the derivative of x. So that also means that x is the integral of v dt. So this gives us a way to go from speed to x, and from x back to speed. But there's one caveat. Let's say we have some function x is equal to t squared. V is 2t. But now, if we have x is equal to t squared plus c, notice that v is still 2t. So in other words, if we simply took the integral of v, we're leaving out, the possibility that there was some constant that was not a function of t that vanished when we took a derivative. So that tells us that any time we calculate an integral, unless we actually have the boundary conditions, we always need to add some constant on the end, because there could be some constant. And so this brings us to to what's called the fundamental theorem of calculus. And all this says is that if we have some function f of t minus f of t0, that this is the same thing as the integral from t0 to t f of t dt. Now notice we don't care about the constant, because if we had, if this was some f of t plus c, we had a plus c here, the minus sign turns that into a minus c, so the c's just cancel out, so we lose the constant there. So that's as much as you really need to know about integrals for this class. And so we're just going to have one more video on basic calculus, just to remind you of the integrals you're expected to know.